What if I told you that the star that gives us life, that warms our days and feeds our planet, has an expiration date? The sun will die, and it's not a matter of if it will happen, but when and how. And the most important question of all, what will happen to us when that day comes? Hello, cosmic explorers, and welcome back to Cosmic Frontiers. Today, we are going to embark on a journey billions of years into the future to witness the most dramatic event in the history of our solar system, the death of the sun. We'll understand why this is inevitable, what the final spectacle of our star will be like, and, of course, we'll explore the fascinating question of how humanity could survive this cosmic apocalypse. Get ready, because the story of our sun is much more explosive than you imagine. And a special thank you to each of you who are following us. Our community of explorers is growing, and we are getting closer and closer to our goal of 1,000 subscribers. Your curiosity is the fuel for this journey. To understand how the sun will die, we first need to understand why it lives. At the heart of our star, there is a nuclear furnace of unimaginable proportions. The temperature there reaches 15 million degrees Celsius, and the pressure is so overwhelming that hydrogen atoms, the sun's main fuel, are forced to fuse. It's like a cosmic party where billions and billions of people are squeezed into a tiny room. The pressure is so great that they end up embracing and becoming one. In the sun, when 4 hydrogen atoms fuse, they create a helium atom. But here's the trick. The mass of a helium atom is slightly less than the mass of the 4 hydrogen atoms combined. This small difference in mass doesn't disappear. It transforms into a colossal amount of energy, following Einstein's famous equation, E equals mc. This is the energy that travels through space and reaches us as light and heat. The sun has been doing this for 4.6 billion years. But, just like a car, it has a limited fuel tank. Every second, the sun converts about 600 million tons of hydrogen into helium. It seems like a lot, but the sun is so gigantic that it still has fuel to burn for a very, very long time. So, for now, everything is fine. The sun is in its most stable phase, called the main sequence. But what happens when the hydrogen in the core starts to run out? Approximately 5 billion years from now, the sun will have consumed most of the hydrogen in its core. The party is ending. Without hydrogen fusion to generate energy and push outwards, gravity, which is always trying to crush the sun, begins to win the battle. The core, now composed mainly of helium, will begin to contract and heat up even more. This is where things get truly dramatic. The temperature in the core will rise so high that the hydrogen in the layer surrounding the core will begin to burn, like embers left around a dying campfire. This new energy source will be even more intense than the previous one, causing the outer layers of the sun to expand violently. The sun will swell, and swell, transforming into a red giant. It will become hundreds of times larger and thousands of times brighter than it is today. It's like a balloon being inflated non-stop. The size will be so absurd that it will swallow Mercury and Venus and Earth. Well, the fate of our planet is still a scientific debate. Some models suggest that Earth will be vaporized, others that we will be pushed into a more distant orbit, but still become a scorched, lifeless world. At this point, Earth will be an inferno. The surface temperature will exceed 1,000 degrees Celsius. The oceans will boil and completely evaporate. The atmosphere will be swept away by the solar wind, and the Earth's crust itself could melt. It will be the definitive end of our home. It's a terrifying thought, isn't it? To know that the very star that gave us life will be responsible for destroying it. But the story doesn't end there. Inside the red giant, the pressure and temperature in the helium core will continue to rise, until they reach a critical point, about 100 million degrees Celsius. At this temperature, something new happens. Helium begins to fuse, creating heavier elements like carbon and oxygen. The sun will have found a new source of fuel. For a brief period, about 1 billion years, it will stabilize, burning helium in its core. But helium is a much less efficient fuel than hydrogen, and soon it too will run out. When the helium is exhausted, gravity will attack again. The carbon and oxygen core will contract, but the sun does not have enough mass to initiate carbon fusion. It's the end of the line for energy production. Without this force to sustain itself, the outer layers of the red giant, already unstable, will be ejected into space in a series of gentle pulses, creating one of the most beautiful sights in the cosmos, a planetary nebula. Be aware, the name Planetary Nebula is a bit misleading. It has nothing to do with planets. It's just a historical name that astronomers gave because, through old telescopes, these gas clouds looked like planetary disks. In reality, they are the mortal remains of a star like our Sun. And what's left at the center of it all? The crushed carbon and oxygen core, now exposed. A white dwarf. This object will be incredibly dense. Imagine taking all the mass of the Sun and compressing it into a sphere the size of Earth. A single teaspoon of white dwarf material would weigh several tons here on Earth. It will be extremely hot at first, glowing with a ghostly white light. But with no energy source of its own, it will spend the rest of eternity, just cooling slowly until it becomes a black dwarf. A cold, dark stellar corpse wandering through the universe. It is the melancholic and, at the same time, beautiful end of our star. Okay, the scenario is apocalyptic. Earth will be destroyed, but we humans are a resilient and ingenious species. 5 billion years is a very long time. If humanity still exists, how could we survive? We have a few options, and they all seem straight out of a science fiction movie. The first and most simple would be evacuation. We would have to become an interstellar species. This means developing technologies to travel to other star systems and find a new home. An Earth 2.0, orbiting a younger, more stable star. We are already looking for such exoplanets, but the journey to reach them is a monumental challenge. The closest star, Proxima Centauri, is 4.2 light-years away. With our current technology, it would take tens of thousands of years to get there. We would need generational ships, which would house many generations of humans, or radically new propulsion technologies. Another, bolder option would be to move Earth. Yes, you heard that right. Scientist Gregory Laughlin proposed that we could use the gravitational assist of a large asteroid or comet. The idea would be to carefully divert one of these celestial bodies so that it passes near Earth, transferring part of its orbital energy to our planet and slowly pushing us into a safer, more distant orbit from the expanding Sun. It would be the largest and most delicate engineering maneuver in history, requiring absurd precision so as not to end up destroying Earth in the process. And the most extreme option, leaving the planet behind and living in gigantic space habitats, like Dyson spheres, theoretical megastructures that could orbit the Sun at a safe distance, or even other stars. We would live in self-sustaining cities in space, independent of any planet. Which of these options do you think is most likely? Leaving the solar system, moving our planet, or building a new home in the vacuum of space? It's fascinating to think about. Let's recap our epic journey. First, we saw that the Sun lives by the nuclear fusion of hydrogen into helium. Second, we discovered that in 5 billion years, when the hydrogen runs out, it will transform into a red giant, swallowing the inner planets and making Earth uninhabitable. And third, we learned that its end will be beautiful and peaceful. It will eject its outer layers to form a planetary nebula, leaving behind a dense, dead core, a white dwarf. The story of the Sun, from its birth to its death, shows us that nothing in the universe is permanent, not even stars. Thinking about the death of the Sun forces us to confront our own fragility, but also our incredible capacity for adaptation and our potential to explore the cosmos. We are a small part of a much larger story, a blink in cosmic time. Now I want to hear from you, Cosmic Explorer. If you could choose, to which known exoplanet should humanity move to survive? Leave your answer here in the comments. Let's create the biggest intergalactic real estate debate on YouTube. And speaking of the future, what universe mystery do you want me to talk about in the next video? Wormholes, dark matter, the origin of life? Leave your suggestions in the comments, because you are the ones who guide the next missions of Cosmic Frontiers. We are on an incredible journey towards 1,000 cosmic explorers. If this video sparked your curiosity about the universe, join our crew by clicking subscribe. Your subscription helps us continue exploring these frontiers. Like this video if it expanded your cosmic horizons, and share it with that friend or family member who also loves the mysteries of the universe. Thanks for exploring the cosmic frontiers with me today. Until the next journey.